All right, so today what we're going to be working on is simplifying rational expressions. And I know that we basically were just doing the polynomials and um, working with all those, but honestly, we just need to move on. We did polynomials. Y'all know how to synthetic divide. Y'all know how to factor polynomials. Y'all know how to graph them, more or less. And honestly, we just need to move on. So we are starting on unit 4. I don't really care that we're not, or that we didn't have like an assessment for unit 3. We're just going to get on to unit 4 because we need to. So unit 4 is going to be rational expressions. And we're going to see a lot of stuff that looks like, well, pretty much everything in here. And I know that this packet is like 17 pages long. I don't know if we'll get to all of it, but we'll get to a lot of it. So, simplifying rational expressions. This is what we're going to start with, and it is pretty simple. So I'll put my name at the top. So we got Mr. Williams. Okay, so we are simplifying 18x to the sixth over 27x to the fourth. And when we simplify these rational expressions, it's basically just like when we would simplify any fraction, pretty much. So if this was just 18 over 27, I know that 18 is 2 times 9. And I know that 27 is 3 times 9. And I have 2 times 9 over 3 times 9. The 9s would cancel out, which means the fraction 18/27 is the same as 2/3. So simplifying fractions, y'all know how to do that. That was like middle school. Middle school. But it's 18x to the sixth divided by 27x to the fourth. But in actuality, the x's in the numerator or denominator don't really affect the 18 or the 27 at all. So this 2/3, that's still going to be right. That's still going to be part of our answer. But then I have x to the sixth divided by x to the fourth. So basically, you just do it separately. So I got x to the sixth over x to the fourth. And if you remember our rules of exponents, when you divide two of the like bases with different exponents, you subtract the exponents. So if I have x to the sixth divided by x to the fourth, that's going to be the same as x to the parentheses 6 minus 4, because you just subtract the exponents. You do the one in the numerator minus the one in the denominator. And x to the 6 minus 4 is x squared. So we're left with 2/3 x squared, which when we simplify that, or when we combine those two, it would be 2x squared over 3. We're going to leave that x squared in the numerator. So just like with the fractions, when we're simplifying those, if I have, I'll come up here. So if I have x to the sixth over x to the fourth, well, I know that x to the sixth is going to be x times x times x times x times x times x. And x to the fourth is going to be x times x times x times x. So I can just go through and cancel out one in the numerator, one in the denominator, one in the numerator, one denominator, one in the numerator, one in the denominator, one in the numerator, one in the denominator. I have none left in the denominator now, and I'm left with the 2 x's in the numerator, which is why I'm left with x squared, because x times x is x squared. And that's how I got my answer, 2x squared over 3. So the simplified form of 18x to the sixth over 27x to the fourth is 2x squared over 3. All right, so let's look at, all right, number 4 is a good one. So number 4, we have 36k to the third m and 24k to the fourth m and to the fifth. So this one has 3 different variables, but just like with the last one, the variables aren't going to affect each other pretty much. So let's see, if I have 36 over 24, so 36 over 24, the greatest common factor of 36 and 24 is going to be 12. So I know 36 is 12 times 3, 24 is 12 times 2. Cancel out the 12s, and I'm left with 3 halves. So 36 24ths turns into 3 halves. Then I have k to the third over k to the fourth. And again, the other variables don't affect each other. So I don't need to worry about the m's, I don't need to worry about the n's, I'm just looking at the k's right now. So k to the third over k to the fourth. And I'm going to rewrite this the same way I wrote the one up top, where I have k to the third equals k times k times k. And k to the fourth is k times k times k times k. And when I cancel things out, those two cancel out, those two cancel out, those two cancel out, and all I'm left with is the 1k in the denominator, which means my answer is going to have a k in the denominator. So let's see, I'll start to compile some things. I'll do it over here. So I have 3 halves, and we said there was 1k in the denominator, no k's left in the numerator. And let's see, m's. So the m's, I have m to the first over m to the first. So that's just saying m over m. That's 1. Anything divided by itself is 1. Neither of them have exponents. So there are no m's in our answer. The m's are canceling each other out. And then we have the n's. So I don't have any n's in the numerator, but I still have 5 n's in the denominator. So I still need to include those 5 n's. So the answer to this problem, 36k to the third m over 24k to the fourth m and to the fifth, is going to be 3 over 2k n to the fifth. And that is the entire answer. And I will put a box around that. All right, cool. Yeah, I'll actually move that to like down there. Looks good. And just to make that 3 a bit more centered, there. Okay, 3 over 2k n to the fifth. And we will do one more in this section here. Okay, I like number 9. So I have negative 16 x squared y to the 7th over, actually, do I like number 9? No. No. I like 8 or 7. We're going to go with 8. We're going to go with 8. Okay, so 120 x to the third y over 25 x y to the fifth. So for this one, again, we're splitting things up into fractions based on like they're grouping based on the variables they're with. So I have 120 over 25 is the first thing I'm going to need here. So 120 over 25. So the factors of 25 are 1, 5, and 25. Nothing else goes into 25. And I know 120 isn't divisible by 25, but I know it's divisible by 5, which means the greatest common factor of both of these is 5. So 25 is 5 times 5. And 120, let's see, I believe that's 24 times 5. It is, yeah. So 24 times 5. And then I can just cancel out these 5s, and I'm left with 24 fifths. Okay, so that is going to be the first part of my fraction. And then I have x to the third over x. So I got x times x times x over x. Cancel things out, and I'm left with 2 x's in the numerator. So I'll come back to my solution here. I said there were 2 x's in the numerator, so I've got x squared up there. And then I have y over y to the fifth. I have y to the first over y to the fifth. So I'm going to have y over y times y times y times y times y. And y'all don't have to write this out like this every time. I just do it so I can visualize it, so I can see, okay, I got 1 y in the numerator, 5 y's in the denominator. I need to cancel some things out. And to do so, the best I can do is cancel out 1 y from both, and I'm left with 4 y's in the denominator. So 5y to the fourth in the denominator, which means the simplified form of 120 x to the third y over 25 x y to the fifth is 24 x squared over 5y to the fourth. And I can't simplify that any further. Okay, and y'all, I want you to do like basically everything else on here. Yeah, everything else on that page. Now let's go down to, it says rational expression worksheet number 2, simplifying. Okay, so this one may look a little bit trickier, and I guess it is, but it's, again, not too bad. So with the last one, when I was determining how I could simplify things, I was factoring the numerator and the denominator, determining what I could pull out of both. So here, I'm going to do the same thing. I have 2x plus 6 over 4x minus 12. So let's see, 2x plus 6, I need to figure out what goes into these. And the greatest common factor between 2x and 6 is 2. So that leaves me with 2 and times x plus 3. Because if I distribute that 2 back in, I get 2x plus 6. And in my denominator, let's see, between 4x and negative 12, it's going to be 4. So I pull out a 4. And 4x divided by 4 is x. Negative 12 divided by 4 is negative 3. So now I need to figure out what I can cancel out. X plus 3 and x minus 3, those don't cancel out. And I cannot just cancel out the x's. I can't do that because it's being added. Earlier I could because they were being multiplied. Everything was being multiplied. There was no addition, there was no subtraction, it was just multiplication and division. Multiplication and division is simpler when we're working with rational expressions than addition or subtraction is. But I have x plus 3, x minus 3. I can't cancel those out because they're not the same thing. But I have 2 and 4, and between 2 and 4, the GCF is going to be 2, which means, well, actually, I'm going to take this 4 and rewrite it as 2 times 2. And then I can cancel some things out because then the 2 in the numerator and 2 in the denominator cancel out. Nothing else cancels out. So all I'm left with is x plus 3 over, and instead of leaving this as 2 parentheses x minus 3, I'm just going to distribute that 2 back in. So 2 times x is 2x. 2 times negative 3 is negative 6. So my solution is x plus 3 over 2x minus 6. That is the simplified form of 2x plus 6 over 4x minus 12. And then I want to look at, what's another good one? These all look good. Okay. So we will go with number 2. Yeah, okay. So this one, well, over here we just had some binomials. We had 2x plus 6, which is a binomial. We had 4x minus 12, which is a binomial, because there's 2 terms to each, and it's not like quadratics because there are no exponents. But now we have an exponent, and we have a quadratic. But we know how to factor this quadratic. So with the binomials, we just factored them by pulling out the GCF, which was a 2 and it was a 4. But here, we can factor this because we know how to factor quadratics. So let's see, I got x squared plus 9x plus 20. And I want to find 2 factors of a times c that add up to b. Remember that? So I want 2 numbers that multiply to be 20 and add to be 9. So if I do that, the 2 numbers that multiply to be 20 but add to be 9 are going to be 4 and 5. So I'm going to take that 4 and 5. And I'll actually just erase that real quick. And I'm going to take this x squared plus 9x plus 20 and use that 4 and 5 in it. So now I got x squared plus 4x plus 5x plus 20. And then I'm going to group x squared and 4x, the GCF. I pull out the GCF, it's just going to be x times x plus 4. And between 5x and 20, the GCF is going to be 5. So I got plus 5 x plus 4, which means the 2 factors of x squared plus 9x plus 20 are x plus 5 and x plus 4. So there is the numerator. It's just x plus 5 times x plus 4. And then I have that denominator, that 2x plus 8. So 2x plus 8, let's see, I'm going to do the same thing I did over here because that's just a binomial. It's not a quadratic, it's just a binomial. And I'm going to pull out the GCF, which in this case is 2. So I can pull out a 2. 2x divided by 2 is x. 8 divided by 2 is 4. So now I'm left with x plus 5 times x plus 4 over 2 times x plus 4. And previously, the only things we were canceling out were like numbers or just monomials. But here, I see that x plus 4 is a factor in both the numerator and the denominator, which means x plus 4 is going to cancel out. So the x plus 4 of x plus 4, that cancels out. And all I'm left with is x plus 5 over 2. So the simplified form of x squared plus 9x plus 20 over 2x plus 8 is x plus 5 over 2. And it's that simple. Just don't overcomplicate it. So yeah. Let me see. I want to do one more in this section. What's a good one? I like number 5. Yeah, I do. Okay, so in the numerator on number 5, I got 3x minus 12. So that's a binomial, so I just need to take out the GCF here. So between 3x and negative 12, the GCF and the only common factor is going to be 3. So that gives me 3 parentheses, and then 3x divided by 3 is x. Negative 12 divided by 3 is negative 4. That gives me 3x minus 4. And then the denominator. Even though this is a quadratic, because it has that x squared, it's still not, we don't have to factor it the same way I factored this one up here. I just have to, it's still a binomial, so I can still just pull out the GCF. And the GCF here is going to be, well, between 3x squared and negative 12x, it's going to be 3x. So 3x, and then let's see, 3x squared divided by 3x, I'm just left with x. Negative 12x divided by 3x, I'm left with negative 4. So now, hopefully, we see some things that can cancel out. And there's more than one thing here, because we got x minus 4 being canceled out. That we can get rid of that. And 3's cancel out. So all I'm left with is that x in the denominator. But my answer isn't just x, because that x is in the denominator. But since everything in the numerator canceled out, my numerator is just 1. So the simplified form of 3x minus 12 over 3x squared minus 12x is 1 over x. And I know I said I would only do one more in this section, but I think I'm going to do another. Let's see. Do I like number 9? Yeah, we'll go for it. We'll go for number 9. Yeah, okay, number 9. So, again, just like with this one up here, number 2, I want to pull out, or I want to factor the quadratic first, because there are 3 terms. It's a quadratic. There are no GCFs. I just got to straight up factor it. So, let's see. I got x squared minus 5x plus 4, which means I'm looking for 2 numbers that are going to multiply to be negative 5, but they're going to add up to be 4. Wait, I did that the wrong way. Okay. 2 numbers that multiply to be 4, but they add up to negative 5. So these 2 numbers that add to negative 5, but they multiply to be 4, it's going to be negative 1 and negative 4. So let's see. That means my numerator here is going to be x squared minus 1x minus 4x plus 4. And then I'm going to group between x squared and negative x. The greatest common factor is x. So when I take x squared divided by x, I'm left with x. X divided by x is 1. So x minus 1. And then I have negative 4x plus 4. And the greatest common factor there is going to be 4, but I'm going to pull out that negative 4 because the first term there is negative. So negative 4, and I'm left with, well, negative 4x divided by negative 4 is x. 4 divided by negative 4 is negative 1, which means the 2 factors of the numerator here are x minus 4 and x minus 1. So that's my numerator. My denominator, I got x squared minus 4x. And again, even though this is a quadratic because there's that exponent, it's still just a binomial, and I see a common factor between those two terms. If it was just x squared minus 4, yeah, I'd want to factor that. I'd want to factor that this way. But this is x squared minus 4x, and I see a greatest common factor. I see the greatest common factor of x. But like I said, if it was just x squared minus 4, there's no common factor between those two, so you'd want to factor it. But x squared minus 4, like I just said, the greatest common factor is x. And x squared divided by x is x. Negative 4x divided by x is negative 4. Which means this is what my new rational expression looks like. X minus 4 times x minus 1 over x times x minus 4. And I'm going to go ahead and cancel some things out. Okay. I got the only thing I can cancel out here. I see an x minus 4 in both the numerator and denominator. So I'm canceling that out. And then I'm left with x minus 1 over x. And I know that when you see this, a lot of people are going to be tempted to cancel out the x's too and just be left with negative 1. You cannot do that. You can't do that because it's x minus 1 in the numerator. If it was x times negative 1 in the numerator, then yeah, you'd be able to do that. But if it is subtraction or addition, you cannot split this up further. This is your answer. So it's x minus 1 over x. Right. So that was number 9. And let's see, I think... Oh yeah, I think this one just is a mix of both those things. Yeah, it looks like it is. So yeah, I don't feel the need to go over, I'll do like one on here. Yeah, I will. Okay, I'll do number 11. Okay, so number 11, we got x squared minus 6x plus 8 over x squared plus 2x minus 24. So first, both of these are quadratics, and both these need to be factored. So the first one, let's see, I have two numbers that are going to multiply to be 8, but add to be negative 6. Two numbers that add up to be negative 6, but multiply to be 8, that's negative 2 and negative 4. So I got x squared minus 2x minus 4x plus 8 for my numerator. And then I group between x squared and negative 2x. The greatest common factor is x. And I'm left with x minus 2. Between negative 4x and 8, the greatest common factor is negative 4. And I'm left with x minus 2, which means the two factors of the numerator here are x minus 4 times x minus 2. All right, and then I'll come over here to do the denominator. There's not very much space on this one, unfortunately. So for the denominator, I want to find the two factors that multiply to this. And that means I'm looking for two numbers that are going to multiply to be negative 24, but they add to be 2. So two numbers that multiply to negative 24 but add up to 2, that is going to be 6 and negative 4. Actually, I'll move this over even further. Okay. So I said it was 6 and negative 4. Or negative 4 and 6. Yeah, negative 4, 6. Just, it doesn't matter what order you put them in. I just, I want to say negative 4, 6. Yeah, so x squared minus 4x plus 6x minus 24. And like I said, it doesn't matter what order you put them in, but the only reason I put the negative first is because otherwise I would be, well, otherwise when I did my grouping, I would have like, I'd have like a negative sign there, and then I would have to like factor out a negative, and I just prefer to factor out positive numbers when I can. Okay. Oop. Okay, so between x squared minus 4x, the greatest common factor here is just x, and I'm left with x minus 4. And between 6x and negative 24, the greatest common factor is 6, and I'm left with x minus 4, which means the two factors of the denominator are x plus 6 and x minus 4. So then I have x plus 6 times x minus 4. And we want to cancel some things. So I have x minus 4 times x minus 2 over x plus 6 over x minus 4. The only thing that's going to cancel out is the x minus 4's. And that means my final solution is just whatever's left, which is going to be x minus 2 over x plus 6. And again, some people are going to be tempted to cancel out the x's and rewrite that negative 2 over 6 as negative 1/3 and say the answer is negative 1/3. No, it's not. The answer is x minus 2 over x plus 6 because I cannot split up that x and that minus 2. I cannot split up that x and that 6. I have to leave it like this. I can't split this up. So yeah, that is basically it for these rational expressions. I am going to post an assignment along with this where you can go in and input your answers. It probably won't be multiple choice. I know I've been giving a lot of multiple choice, but it probably will just be like type the answer. And I believe that's it. So remember, just factor whichever way possible. Like if it's a quadratic, you know how to factor a quadratic. If it's a binomial, take out the GCF, you know how to factor a binomial. Otherwise, do your best, guys. And with the exponents, you just subtract. Oh yeah, that's one thing that I didn't really say, but with the exponents, you just subtract. Like I had y to the first over y to the fifth. 1 minus 5 is 4, or negative 4, which is why I had that 4 in the denominator. And then I had x to the third over x to the first. 3 minus 1 is 2. And since it was a positive 2, it was in the numerator. So x squared was in the numerator. And same thing here. I had k to the third over k to the fourth. 3 minus 4 is negative 1, which means I was left with k to the first. And since it was negative, it was in the denominator. The m over the m cancel out. Yeah, subtract those exponents. And I'm posting that assignment, so be diligent. I don't think I'll cover all of those. And like I said, we probably will get to all of this packet at some point, or not all of it, but most of it. But for now, I just want pages 1, 2, and 3 to be worked on. So yeah, that's all.